Picture the ocean. Vast, mysterious, impossible to fully explore. Yet, a single drop can reveal a world of life. That's the power of sampling, understanding the whole by examining a part. Sampling is the foundation of research, shaping how we see reality. A good sample gives us clarity, a bad one distorts the truth. Today, we'll navigate the two main streams: probability and non-probability sampling. From random chance to targeted selection, you'll learn how to choose the right method for your quest. Let's dive in. Imagine a cosmic lottery where every star in the sky has an equal chance of being chosen, no matter how bright or dim. That's the essence of simple random sampling, a process where every individual in a population stands an equal shot at selection, just like each star in the universe. In practice, this means assigning each member of your group a unique number, then using a tool, like a random number generator or even drawing lots from a hat, to pick your sample. There's no favoritism, no hidden patterns, just pure chance guiding the process. This method is celebrated for its fairness. It's the gold standard in research because it mirrors the diversity of the population, ensuring that every subgroup has a chance to be represented. If you have a complete list of everyone in your population, simple random sampling can minimize selection bias and produce results that are truly representative. But here's the catch. Simple random sampling only works perfectly when you have a full, accurate list of every individual in your population. For small, well-defined groups, like a classroom or a single neighborhood, it's ideal. You can easily assign numbers and ensure everyone has a fair shot. However, when your population is massive or spread out, think of an entire country or a bustling city, getting that complete list becomes a real challenge. In these cases, simple random sampling can be impractical or even impossible. But when you can use it, your findings are highly generalizable, giving you confidence that your results reflect the broader group. Simple random sampling is about letting go of control and trusting the laws of probability. It's the closest we get to creating a true microcosm of the whole population, where every voice has an equal chance of being heard. But when that complete list is out of reach, researchers must turn to other sampling methods. Still, the principle of fairness through chance remains at the heart of good research, reminding us why simple random sampling is so powerful when it's possible. Systematic sampling brings order to randomness. It's a method that helps researchers cut through chaos and create structure, especially when faced with overwhelming amounts of data. Instead of picking samples haphazardly, systematic sampling gives you a clear, repeatable process. Picture a line of stars. Pick a random starting point, then select every nth star. This could mean every 5th, 10th, or 20th item, depending on your needs. The key is consistency. After that first random pick, you follow a set interval, moving through your list with precision. It's efficient, especially for large populations. One random start, then a steady rhythm. This approach is much faster than simple random sampling, and it's easy to implement even with thousands of entries. You don't need to generate a new random number for every selection, just the first. This spreads your sample evenly, saving time and effort. It ensures that your sample covers the entire population, not just one cluster or section. Imagine walking through a library and pulling every 10th book. You get a broad, representative mix. But beware, if there's a hidden pattern in your list, you might accidentally bias your sample. For example, if your data is sorted in a way that repeats every nth entry, your systematic approach could line up with that pattern and miss important variation. For example, if every 10th star is a red giant and you pick every 10th, your sample could be skewed. This is why it's crucial to understand your data's structure before you begin. Always check for patterns before you start. Shuffle your list if needed. Randomizing the order can help break up any hidden cycles or repetitions, making your systematic sample more reliable and unbiased. Systematic sampling is a powerful, practical tool when used wisely. It's a dance between chance and order, blending randomness with structure. When you master this method, you can move confidently through even the largest data sets. Use it to move efficiently through your data, but stay vigilant for hidden traps. With careful planning and a watchful eye, systematic sampling can help you uncover insights that might otherwise be lost in the noise. Populations are rarely uniform. They're layered and complex, shaped by factors like age, income, region, education, or occupation. Each of these layers, or strata, represents a unique segment of the whole, and together they form the intricate tapestry of any population you want to study. Stratified sampling is a method that honors and leverages this diversity, ensuring that every important subgroup is recognized and included in your research. The process begins by dividing your population into distinct strata, groups that share a key characteristic such as gender, ethnicity, or age bracket. This step is crucial, as it sets the foundation for a representative sample. Next, you sample from each stratum, often in proportion to their size within the overall population. This way, no group is overlooked or overrepresented. By doing this, you guarantee that every subgroup, no matter how small or large, has a voice in your results. The outcome? A sample that truly mirrors the complexity and richness of the entire population, capturing nuances that might otherwise be missed. Stratified sampling increases the precision of your estimates and helps prevent missing important groups, especially those that are small but significant. It's the ideal approach when you need both a broad overview and deep insights into specific subgroups within your data. However, there's a challenge. You need detailed, accurate information about your population to define the right strata. Without this, your sample may not be truly representative. Poorly defined strata can lead to skewed results, undermining the reliability of your findings and potentially missing key insights. But when stratified sampling is done right, it brings clarity and confidence to your research, allowing you to draw conclusions that truly reflect your population. It's a sophisticated lens for seeing the true structure of your universe, revealing patterns and relationships that might otherwise remain hidden. Use stratified sampling when diversity matters, and when you want your research to reflect the real world in all its complexity. Sometimes your population is too vast or scattered for a full list. Enter cluster sampling. Divide the population into natural groups like cities, schools, or galaxies. Randomly select a few clusters, then study everyone within them. Or, in multi-stage sampling, sample within clusters too. It's practical and cost-effective for large, spread-out populations. The trade-off? Clusters may be more alike inside than between, increasing sampling error. You may need a larger sample to get reliable results. Still, cluster sampling makes big studies possible. It's the method for mapping the unknown one island at a time. Use it when logistics make other methods impossible. Just remember, efficiency comes at the cost of some precision. Balance practicality with your need for accuracy. Now we enter the world of non-probability sampling. Convenient sampling is the easiest and riskiest method. You sample whoever is easiest to reach: friends, passers-by, volunteers. It's fast, cheap, and perfect for pilot studies or early exploration. But it's almost always biased. Your sample likely won't represent the whole population. The results can be misleading, painting a false picture of reality. Use convenient sampling only for quick insights or testing ideas. Never base big decisions or generalizations on it. It's a starting point, not a destination. Treat its findings with caution. Remember, easy data isn't always true data. Sometimes you need experts or rare cases, not averages. Purposive sampling lets you handpick participants based on your research goals. It's about depth, not breadth, choosing those with unique knowledge or experience. Used in qualitative research, it's perfect for deep dives into specific phenomena. You might seek Nobel laureates, survivors, or outliers, the strength-rich, detailed insights from the right people. The risk: your judgment shapes the sample, so bias is a constant threat. Findings can't be generalized statistically, but they can illuminate complex issues. Use purposive sampling when you need to understand the exceptional, not the average. It's a specialist's tool, powerful but not for every job.